Human bodies are diverse, but current human pose and shape regressors tend to predict mean-shaped bodies. One reason is their focus on body pose, which can easily be labeled via 2D key points. But key points are not sufficient to estimate body shape. Imagine somebody gains weight. Their shape changes while the skeleton remains the same. Recent methods use silhouettes to address this problem, but they tend to overestimate body shape when a person wears loose clothing. Ideally, to train a 3D body shape regressor, we'd have a dataset of images in the wild with ground truth 3D scans, or shape parameters of a body model like SimpleX. If you don't know SimpleX, think of a function that takes pose and shape parameters as input and outputs a 3D mesh. Unfortunately, we cannot collect thousands of 3D scans paired with images in the wild. So how can we address this lack of training data? Our insight is to use language. Look at this woman. How would you describe her body shape? I would describe her as tall, curvy, and pear-shaped. We can even provide ratings to indicate how tall and how curvy she is. But is this sufficient to train a regressor? Surprisingly, yes. We show that 15 words are enough to train a network that estimates metrically accurate body shape. To do this, we draw inspiration from Body Talk, where the authors train a model to predict attribute ratings from shape parameters and vice versa. From Body Talk, we choose the 15 most relevant words for males and females. Then we ask workers on Amazon Mechanical Turk to indicate how much an attribute applies to a body shape from the Caesar dataset. With the Caesar data, we fit a polynomial model, shape to attribute, or S to A for short, that predicts attribute ratings from SimpleX shape parameters. Our model predicts that Bob has broad shoulders, is rather masculine, muscular, and short. Next, we collect images from model agency websites. For each model, we collect the same attribute ratings as we collected for Caesar. Finally, we use our new data set of model images and attribute annotations in network training. Our network Shapey outputs SimpleX pose and shape parameters. The SimpleX shape is passed to our shape to attribute module. We define losses that encourage predicted attribute ratings to be similar to the ground truth. Here are some qualitative results. Note how Shapey precisely captures subtle changes in body shape and, compared with prior art, is less confused by clothing. To quantitatively evaluate Shapey, we captured a new dataset because existing benchmarks either have few subjects or no ground truth body shape. Our human bodies in the wild dataset consists of ground truth scans of 25 subjects and images taken in the lab and in the wild. Shapey is significantly more accurate than state-of-the-art on HBW. Our results also show that silhouettes are a good approach when people wear tight clothing. The key takeaway is that linguistic descriptions of body shape are sufficient to train a regressor to estimate metrically accurate 3D shape. Maybe we can use language beyond human bodies to learn 3D shape from images. In the paper, we do much more than what I could present today. For example, we also collect model measurements and use those in regressor training. Please come to our poster to learn more. Thank you for listening.